Sean?
I'm Sean Chambers. I'm the Director of Software Development at ACI in Palm Coast, so I tell him what to do every day. And I've been doing software development for about the last 15, 16 years in C#, a little bit of Java, JavaScript, Ruby, Python, so on and so forth. And I have a slide where I'll continue to blab on about that when we get to that point. All right, so originally Kai came to me and said, hey, do you want to do a presentation? I said, only if I get to choose what the topic is. And I said, what better topic than REST APIs and web standards, because that's my soapbox, as Todd has probably heard quite often in the office, is saying this company is doing it wrong. This is not a REST API. It's anything but a REST API, but I won't get my soapbox out in this session because that's a... So before I start on the first slide here, to serve as an example of how widespread REST APIs are on the web and how it's a foundational portion of the World Wide Web. Clearly everybody's here has used the World Wide Web and surfed the World Wide Web. Now, if everybody can raise their hands, has actually used a REST API before. So at that point, everybody at the table, if you surf the World Wide Web, you can raise your hand, because the World Wide Web is one gigantic REST API. The World Wide Web is an implementation of a REST API, or it follows the practices and constraints of a REST API. REST APIs are not a standard, it's not a specification, it's not something that you can say that is adhered to exactly, or you can say that you follow the guidelines and you follow the constraints. A REST API is actually, or REST in general, is actually a set of architecture principles that you can follow when designing something. And that goes to software. It just so happens that HTTP follows all those constraints and has all of the constraints of REST built into it. 97 or 98, and I was playing with HTML and HTTP a couple of years earlier than that. Probably 96 is when I first got my hands on it. At that point, they had already published the HTTP 1.1 spec, which is what pretty much all of the web uses today, is HTTP 1.1. Languages that I've known, I didn't put VB on there because I don't like to say that I know VB. I think some other people, Todd has a deep knowledge. We worked together probably almost 10 years ago at a place down in South Daytona, and they use VB. Mainly now at ACI we write C#, and now we're getting into a lot more JavaScript, HTML, more HTML5 features and interactive websites and things like that. I also play with Ruby and Python often. But that's more of, if I just want to play with something, I'll dip into those languages. And lately I started playing with Node.js, which is a JavaScript runtime that you can run on a server. So they have a really cool Node package manager. You can plug in modules to it. So if you want to have a web server, or if you want to push files to Amazon S3, they have, it's called NPM. It's pretty interesting if you take a look at it. So today what we do at ACI is leveraging REST APIs as well as messaging solutions. We build distributed software systems for the real estate and appraisal industry. So there's a metric that gets thrown around the office. If you've had an appraisal done in the last 10 years, there is a 70 to 80% chance that at some point that appraisal or that data has gone through one of our systems. We have multiple products for lenders like Bank of America, Chase. We also sell to AMCs, which are kind of the middlemen. And then we also have products that we sell to the appraiser. So that's kind of the industry we're in with ACI, is kind of the appraisal and real estate industry. As well as analytics, starting to gather a lot of data and sell that back to we gather the data from the lenders and then we sell the data back to them in a different form. So that's kind of interesting stuff that we're getting into now. So at a high level, these are the topics that I have here that we'll try to cover today. I don't want to spend too much time talking about the background and HTTP and stuff like that, but in order to talk about REST, you should really have a good understanding of how the HTTP protocol itself works. First, I'll cover some background of the World Wide Web and HTTP. Then I'll go into some basics of HTTP. And then we'll get into ReST, which actually stands for Representational State Transfer, which is a mouthful, but we'll explain that. And then I have a couple of samples. I have a full client-side sample, which is all written in JavaScript using jQuery. And then I have a C# sample that I actually have an MVC site set up that we can push and pull with a REST API to this C# site I have set up on the local machine. So that's kind of a high level what we'll cover today. So the first section kind of talk about web standards and the protocol. Does anybody know who this guy is here? Anybody seen him before?
Alex would know him.
I think Alex raised his hand.
Alex, what's his name?
That's right, yep. So,
Right?
so this guy, Tim Berners-Lee, was the one that originally created the World Wide Web. When he was at CERN, and this was going back probably about the early 90s, he and his team there, they created the first web server and they wrote the first spec for HTTP, which was HTTP 0.9. As an example, and I have a couple of tabs here, this is the original spec for HTTP 0.9 that was set up in 1991. As you can see, it's actually pretty small and it doesn't actually contain a lot of information, but this was actually the first draft, and the World Wide Web Consortium mirrored all this data, so all of this stuff is still up on the World Wide Web. The first web server that he set this up on, does anybody know NextStep? Did you hear of NextStep in the early 90s? NextStep was a company when Jobs left Apple in the early 90s. He left Apple and went and created a company called NextStep. The first web server that Tim Berners-Lee set up an HTTP server on was actually on a NextStep computer, which is one of Steve Jobs' computers. And this is in CERN in Europe. So this is an interesting page to show. That covers kind of the first web server, the first rendering engine as well for HTML pages was on that NextStep computer. Very quickly after they published this spec, they started working on HTTP 1.0. Well, HTTP 1.0 had significantly more implementation details and spec than the 0.9 specification, but shortly thereafter they published a 1.1 spec. The 1.1 spec, and actually I forgot to skip this part, is this, so once they created the first 0.9 specification here of what HTTP is, this was the first website ever created. And this was by Tim Berners-Lee. This is still available on the web, which says a lot to HTTP as a protocol in HTML. Still to this day, over, over 20 years later, I can still render that original website on this browser right here. And that shows how solid and foundational this specification is. That how many computer problems can you say you can load up a DOS program and still run on a computer with no problems today? Very difficult, or almost impossible. But the World Wide Web still renders these pages to this day. Now, there was no image tags, there was no tables. It was just basically text. And it was kind of interesting because he actually has links here. And the one that I saw that was, when you go to what's out there, this says there is no top to the World Wide Web, but this is the top of the World Wide Web. And he goes into details about how, what the web is and how it's structured and stuff like that. So there's the first web page ever created. The HTTP 1.1 spec is a little bit deeper and much more solidified than the 0.9 spec was. And if you've never read it or never looked at it, I would suggest going and reading it. It's a little bit of a dry read, but it's very interesting to see all the different things that they originally set forth in HTTP 1.1. So that kind of gives a high overview of Tim Berners-Lee. When Tim Berners-Lee, after they created, or while they were trying to solidify the 1.1 spec, Tim Berners-Lee went and created the W3C. Has anybody ever gone to w3c.org? And it's still around to this day. W3C is a World Wide Web Consortium. So all standards, if anybody's, I'm sure, heard of HTML5 features and things like that, all of those HTML5 features come out of the World Wide Web Consortium. The World Wide Web Consortium, what they do is, I had an example, and I couldn't find it when I was putting together the last of the slides. It was a snippet from an old mailing list back in 1993 when there was a discussion of, I'd like to propose a new tag called IMG, and I'm sure everybody's seen the image tag in web pages. And it was the original discussion of what the image tag was and what attributes it had. And in this mailing list discussion, they kicked around, well, what about this? This other guy said, I was thinking about the icon tag. And this guy said, well, I actually had the include tag. And that's the original process that went forth of creating these standards. So what the World Wide Web Consortium did was they formalized this more, and they came up with what they call WG, which is a working group. So they create these charters for these working groups, and they set a start date and an end date for the working group. And they have a goal, and then they specify what the goals are, what the output's going to be. And then what will happen is these people will collaborate on this working group mailing list, create what they think is a good spec, or some of them don't have specs, some of them were just a discussion. And once they're done discussing that, it then goes through a process of going to a working draft, and then it goes to a candidate release. And each of these phases, it gets more and more solidified until eventually at the end, the World Wide Web Consortium, if it has reached its goals, publish this as a W3C recommendation. At that point, this is solidified as a standard, and they pass it around to all the browser manufacturers, Google, Microsoft, Firefox, and say, hey, this is a new specification we have. You guys should consider implementing this in your browsers. Now, in the late 90s, I'm sure everybody remembers the browser wars that took place. And is really a bad place for standards at that time because Microsoft was going down their path. I mean, sure, everybody remembers the Blink tag and the Marquee tag. The browser manufacturers went down all these different paths of creating their own tags that didn't meet standards. So if you had a Blink tag, it would blink text, as horrible as that is, in Internet Explorer, but other browsers like Netscape would completely ignore that tag and it wouldn't render. Since then, a lot of these manufacturers, especially now that HTML5 has been gone to a W3C recommendation, a lot of the browser companies have gone back to those standards and say, okay, let's clear the deck and make sure that all the browsers implement these specifications because it's going to be easier for everybody. Roy Fielding worked with Tim Berners-Lee at CERN when they were first developing the 1.1 specification. Roy Fielding published, he was also, if anybody's heard of the Apache web server that runs on Linux, he was the original, one of the first guys to work on the Apache web server project was Roy Fielding after he left CERN and after Tim Berners-Lee went and formed the W3C. He published a doctorate dissertation in 2000, and the title is very long. It's called Architecture Styles and the Design of Network-Based Software Architecture. In that dissertation, he speaks specifically to REST. A lot of the concepts and ideas that are in 1.1 are tied to representational state transfer, and I'll show that in some samples. And in his dissertation, he describes what these constraints are, even though it was in the 1.1 spec, and how everybody's doing it wrong, and nobody's following the right constraints. Everybody's calling their API REST API when it's really not a REST API, or it doesn't follow all the constraints of what a REST API should be. So this is another, Tim Berners-Lee and Roy Fielding are two important people when we're talking about web standards and we're talking about REST APIs. So I would recommend going and taking a look at his dissertations online. And so this is another site that recently came out, and the World Wide Web Consortium is a little bit, the World Wide Web Consortium, the information they have published there is very, very vast. They have a lot of information on the World Wide Web Consortium. It talks about all things, how to do this with JavaScript, how to write this HTML, how to do these things. This is a newer site that has come up in the last couple of years, I think in the last year or two, and this is a really, really good resource for learning all things related to HTTP and HTML, HTML5 features that are now supported in most browsers. They have videos on here. There's community discussions. This is a very, very good site if you want to dig into this stuff. But I would also recommend looking at W3C. And there's quite a few companies that have contributed to webplatform.org, and large ones at that: Facebook, Adobe, Intel, Google, Microsoft. All these companies are involved with webplatform.org for publishing this documentation on how these things should be set up. And then they go to pretty simple levels here, even how CSS works, how Canvas works, the file API that's in HTML5. So there's a lot of good content on this site that is a good place to learn a lot of these features and how to follow the standards appropriately. That's another good site to take a look at. So now getting into HTTP. HTTP is an acronym for Hypertext Transfer Protocol. So HTTP solidifies and documents how the World Wide Web and how the communication works when you visit a website. Of course, at first you have DNS, so you punch in, google.com, DNS gets called, and a DNS lookup occurs that tells your computer what the IP address is. At that point, HTTP is a couple things. It's a request response protocol. So that means that your computer makes a request to the web server, say, hey, I'm looking for this page. And the server, if it finds that page, will return that page to you. And that's the whole scope of a session in HTTP. It's a request and a response. Now, there's newer things that kind of don't follow that same pattern. There's a thing in HTML5 called WebSockets, which holds open a long-running connection, but I won't really dive into that because we could talk about that for an hour and a half. Request response, another key piece here is that the HTTP protocol is stateless. And what I mean by stateless is outside of that request and that response, that web server holds no state. It does not know from one request to the next that you're the same person coming to the site. And that's a very, very important part of HTTP because that simplifies a large degree of things that take place. So the web server does not have to maintain anything in memory. It doesn't have to keep track of you, which is why they brought in other features of cookies. So whenever you visit a website, you sign in with Google, usually, most sites, they'll take a cookie and throw the cookie down on your machine, and usually it's encrypted so nobody can read it, so that on each request that you send to the server, that cookie comes back up to the server, and the server can read that cookie and determine if you've already been authenticated or not. Because it's a stateless protocol, authentication, the web server has no idea of authentication from one request to the next. So there's been various features that have been added to add stateful features to HTTP, but HTTP itself is completely stateless. The server will maintain no information between requests, which brings a couple interesting things to the table because a lot of the stuff today is interactive. And I'll show that in an example. There's ways now that you can get around that with various other features to make it seem like you're on one page application and you're working in that the whole time. So this is a sample of an HTTP request, and there's three main parts to an HTTP request to the server. The first part is the very first line, and the first thing that's required is a verb, and I have another slide that we can talk about the verbs in HTTP. Then the second part there's a space followed by a path to the file that you're looking for, and then the version of HTTP that this client is using or is expecting for the server to respond with. That first line in HTTP is absolutely required no matter what. The second line, and so that's the very first line. This section is called the request headers. The second line specifies what host the request is going to be made to. That's then combined with the path on the first line, so it just goes to www.google.com/, which would be the root of the Google website. The next line, accept encoding, tells the web server what type of encoding the client can accept, and all the accept headers are all information that the client is telling the server, here's things that I can work with. The next line says, here's the character set that I accept, which is UTF-8, which is most client browsers will use that. Cache control, it's telling the server, I don't want any cache. The next one says what language the client browser accepts. The first one is English, and the Q means a quality score, which means you can weight these. So the client browser is saying, I prefer English. A lower score of 0.3 is English US, so it's saying, If you can't give me English, then I'll fall back to English US. Now, if the web server can't fall on either one of those, you'll get a status code saying, I can't serve you up a response because I don't have a language that you're able to accept. So depending on these headers, the web server may have different paths that it responds with. The refer tells the web server, and that's an optional header, it tells the web server, here's where I'm coming from. I am coming from this website over here, and now I'm making a request to you. So commonly, if I were to have a link in a page at www.mywebsite.com, and I have a link that goes to www.google.com, when I click that link in my browser, that refer header is added to the request, saying that this link came from mywebsite.com. That is optional, though. So a TCP connection is opened up with the web server. Usually the default is port 80, as I'm sure everybody's familiar with, but you can specify a different port. After that connection is opened and accepted, and the server processes that request, it'll respond with this. Now, if you use a raw, and I have a client here that we can actually look at requests going up back and forth. When you go to Google, Google doesn't actually respond with the Google search page. What Google responds with is a different status code, which is 302. And we'll get into status codes here in a minute. 302 is found. Say, hey, you requested this page and I found it, but it's actually over here at this other location. So go ahead and request this page over here. The reason Google is doing that, you can actually see here, there's a couple of parameters that they add to the URL that they're pointing you to, and they do this for tracking. So they probably, there's various reasons you can do a 302 redirect, but they append additional information probably for tracking or statistics or whatever the case may be. So in this instance, they did 302 found, and the content type, the web server is telling the client, the content type that I'm returning to you is text HTML. So I'm returning you an HTML page. The next one is the length of the response, which is that HTML there. And then it's followed by the actual, what's called the response body. So the request only has the request headers, and a GET request never has a body. But the server responds with response headers, and that's what they're called, content type, content length, and there's a number of other ones I didn't show here, and the response body, which is the actual web page. In this instance, I wanted to show this example of a 302 redirect. When the client sees that the response to the 302, what the client will do is, completely unbeknownst to you, it'll make another GET request at that new URL, and then that response, it'll show you that page. So 302 redirects are completely transparent to you using a browser, but they are occurring behind the scenes. So in this instance, when you do a GET request to Google, it responds with a 302. The client browser then says, okay, the server told me that I need to go to this resource over here. So then the client browser will actually make another GET request to that page and then respond with the actual Google search page.
And this is where it passes in the query string looking stuff?
In the response here, yeah, so it's appended on to the end here, the question mark, and that's the query string which you can use to pass parameters. So that URL will be used, and it's actually in the response headers, but I don't have it here, is it'll make a GET request with the query string, which then Google is using those parameters, and they're pulling those in, whatever they're doing with those. So that's at a high level, that's kind of a simple example of a request response and everything that's occurring there.
So you think that's like for analytics? And
for this instance, I was looking into the request. I'm not sure what the EI variable is. It's obviously something that's hashed. And actually, Nick, that's sitting here now, you've done this excessively.
Were you logged in when you went to Google?
I don't believe that I was, because I did this from like a website that can just send arbitrary requests. The GWS RD, I'm not sure what that one means either, without knowing what they're using those parameters or what they're named. I'm assuming GWS is Google Web Services, and then the RD is probably a redirect or something to that effect. So they want to know that this person was actually, they got a redirect, and then they're pulling that into some other area of their system further down the line. And as well as the status codes, probably using status codes, and we're only starting to come back around to those things now, almost 20 years later. Everybody's finally, okay, let's go back to those principles that they originally specified here and use these for what they're actually used for. There's other verbs. There's options, and I think I have a sample. I show you options. Options just sends a request to the server so the client will know what verbs that resource accepts. There's patch, which is for partial updates. There's trace that will trace what proxies the traffic went through to get to the end server. Those ones are less commonly used, but these are the most common ones. Status codes. Status codes, I'm sure everybody has seen this status code at one point or another, 404. The one I had in the sample here was 302 found. After this client was redirected, it would have got a 200, which is okay. And I have a sample of the verbs here. And if anybody can tell me what an odd one is there that you see on the list of the available status codes. 418, I'm a teapot. And that's part of the hypertext coffee pot control protocol, which was a April Fool's joke that I believe was in the year 2000. 418 it wouldn't be in 2000, it was back in 96 or 97 or something. 418 is in the HTTP 1.1 spec, and it's I'm a teapot. And the idea was that you could have a teapot that was hooked up somehow as a web server, and it could respond to brew coffee requests and such.
We still use it today when we run out of coffee.
Now, it says in the spec that 418 is just a joke and no real web servers are expected to implement that or support that. If you did send a 418 to a web server, we can test that out here in the sample, you'd probably get something, what's not supported is, the status code for not supported is 406. 402 or 406 is not supported. We can dig into that. So here's all the most common status codes that you'll find. 304 versus 302. 304 is temporary redirect. 302 is permanent redirect. 200 is the most common one you'll have. That's okay, everything went well, here's your response. And these status codes will always come back from the server that's on the response. 400 is bad requests. 401 is unauthorized, so if you don't have authorization to do a specific action on a resource. 403 is forbidden. Yes, unauthorized means you're not authenticated. Forbidden means you're not allowed to do that. 404, as everybody's seen, is not found. The server's saying, I can't find that resource that you asked for. 418, we covered. 500 is internal server error, which you've probably seen that one frequently as well. 503 is bad gateway. Commonly, you'll see that on web services if there's some problem in the tubes or the pipes. 503 will be bad gateway. There's some server down the line that it can't find the target server that the request is going to. And this, you can kind of group these status codes into these groups. The 200 series is used, okay, everything's good. Here's a response, you're okay. And there's a number of other status codes in 200, and they all mean, everything's good. The 300 series means, okay, everything's good, but there's some further action needed by you, the client. The 400 series means you, the client, when you made a request, you did something wrong, and I cannot fulfill that request. So look at the status code and change your request and try again. The 500 series means you, the client, did everything correctly, but the server did something wrong, or another server down the line did something wrong. So that's an easy way to look at those status codes and kind of get an idea of where the problem is. Usually most web servers will implement those properly. When you're doing a post, the proper response code is actually a 201 created if that resource is actually created. A lot of APIs don't do that. They just respond with a 200 OK. So some APIs don't adhere to these exactly as they should according to REST guidelines. But as long as they're not always just returning a 500 server error, because then you're not able to do anything. So at a high level, that's kind of the status codes. So far we covered the verbs, which is post, put, get, delete. We cover status codes. And the other part here is, originally these were called MIME types. I'm sure you heard of MIME types or read about them. They actually changed the naming to, the proper terminology for them now are internet media types. And the internet media types, this ties in specifically to REST, and this is a kind of a core principle. The MIME types are a representation of a resource, if that makes any sense. So for instance, if I, the client, am asking a web server, hey, I accept text HTML. The server is going to try to find a representation of that resource that is text HTML and return that to you. Because the client is saying, I don't want XML, I don't want JSON, I don't want, plain text, I want HTML. If the server is able to fulfill that response, it will get a representation of that resource in HTML and return it to you. There's various other internet media types here. The most common ones that you'll see are text HTML, text plain, which would be like a text file that you're downloading from a web server, text XML. There's also application XML, which is XML content type. And then a more common one when you're working with REST APIs and they're using the JSON format is application JSON. You can also implement your own media types. What they recommend, if you're setting up your own media type, they recommend that you use application/VND. Though that root media type is reserved for custom media types that don't fit in the standard set of media types. There is an interesting site here.
Sean, can I just interrupt you?
Absolutely.
Will you be able to share your deck after?
Absolutely, yep. I will share it on Google Drive or...
Slide share, maybe put it up there.
Yep, absolutely. So this page is updated quite frequently. You can see actually this page was updated yesterday. This is a registry of all publicly known media types. And you'll find all the media types that are actually documented and supported. And this is where the documentation of a media type begins. So let's say you ask for, and there's some really interesting ones here. So I recommend, and I'll share all these links. I recommend going to this page and looking at some of the media types that are implemented, because a lot of companies that are trying to, let's say they're creating a REST API and they have a custom media type and they want to spread the information on what this media type is, they'll post it to this page.
So that others can consume it?
Exactly, because then if they're using their API and they set the accept header to that media type, they're going to get the media type back that is documented on this page. So this serves as a specification of media types that may be returned. Now normally if in a lot of the REST APIs that we build, we'll just return application JSON, because either one, it's for internal consumption, or two, we have documentation internally that we publish and then give to the client if somebody is integrating with us. And it's not a media type that we want to give out to the public. But these are media types that a company has decided, this media type we want everybody to know about, so we're going to go to this page and we're going to publish it. Usually the application ones are reserved for application specific or something that is not in the standard set of media types that are usually used in HTTP. Like for instance, there was some interesting ones here if we look for VND. So here's some interesting vendor ones. So this is going to be application/VND. So for instance, here's Adobe Flash Movie. So if you go to this page, this was published in 9/6/2013. This is a specification about Flash movies for that are implemented using Adobe technology. There's some other interesting ones here that I found. Here's some ones about Bluetooth. If you have an internet media type and you have to work with it on REST, there's specification on how to work with those media types. And there's a large number of ones here, and a lot of these are company specific. There's Dolby Mobile 1 and Dolby Mobile 2. That's something for mobile video, or Dolby or something like that. There's a bunch of DVD ones. So you can dig through this. A lot of these go back really far. Like here's ones for Epson printers. I mean, this one goes back. Usually they have a date. Sometimes they don't have a date on, which doesn't look like it does. I can't find a date there. But this is an interesting page to go to look at media types and how these are implemented. Back to the presentation here. So the root of the media types on the left side where it says text, that's called the type. And then it's followed by a slash and then a subtype. So there'll be multiple root types. So you'll have text XML, text plain, text HTML. And then after that you have a subtype. Those are the two main types, or the two main areas of a media type. It'll always be a type, followed by a slash, followed by a subtype. And if you go into the HTTP 1.1 spec, how these are even named is specified in 1.1. You have to follow rules when you're creating a media type, at least how you're naming it. And there's certain characters that are allowed to be appended on to that media type. You can use plus signs. So if I have a custom media type that I'm doing, application slash vnd.aci dot person. If I had an XML and a JSON representation, I might do plus XML on the end of that, or plus JSON, and that would tell the server that they want an XML representation of person or a JSON representation of a person. So there's various other things you can append onto that media type to give additional information. The next section, representational state transfer, which is a mouthful. That's what ReST stands for. It's actually kind of an acronym there, I guess you'd call it, or whatever that's called. What representational state transfer means is you are asking the server for a resource, and that's what the name, what it's called, a resource, and you're asking for a representation of that resource. And what ReST is doing is it's taking the state of that resource and it's transferring it to the client. And then at that point, you can make modifications to that resource and push your state back up to the server and see if that server will accept that state transfer of that resource. That's a lot to encompass, but at a basic level, that's what's occurring there. There's three main parts of ReST as far as the best I could distill it down to the easiest way to explain it. The first is the nouns, which are your resources. For instance, person, address, bank account, various things like that. Those are called resources. The verbs are the verbs that you can take action on those resources. So I want to create a person. I want to update a person. I want to delete a person. So in that you would post or put or delete for that resource. And the third part is representations of a resource. So for instance, when you go to a website, you're saying, I want text HTML. That's an HTML representation of the resource you asked for at www.google.com. If I put an accept header of text XML and I send it to that and the server can serve up an XML representation, it's still the same resource. It's just an XML representation of that resource. So a lot of resources, usually, depending on the API, can serve up different representations of that same resource. So that's where the representations come in. So I'll run through this slide real quick, and I mainly put it here for documentation if you guys download the slide, because the high-level REST constraints that Roy Fielding and the fathers and the designers of HTTP 1.1 said that what REST should support, this is actually from his dissertation, it should be a client-server. And REST as an architectural principle transcends HTTP. It just so happens that HTTP follows all those REST constraints. But REST at a higher level needs to follow these constraints. According to Roy Fielding, he's the only one that can tell you you're doing it wrong and this isn't REST. It should be a client server, so it should be request response. It should be stateless. It should be cacheable, so those resources should be able to be cached and served, or cached on the client, and then the client can just use a cache of that resource rather than getting a new one. It's a layered system, so in HTTP that's proxies that the traffic would go through in order to get to your target server. Code on demand, which in HTTP is like JavaScript, so you can serve up JavaScript and that can run on the client in real time. That's what they mean by code on demand. It's a uniform interface. Uniform interface in HTTP are URL, Uniform Resource Locator, URI, which actually a uniform interface is a URI, and there's a difference there. A URL is a URI, but a URI is not a URL. A URI is a Uniform Resource Identifier, which is a specific identifier to get to a specific resource, which is the URLs. www.google.com/home. That resource is a URI, and that is unique to that page. No other site in the world can claim that they have that resource. That resource is owned by Google, and Google has it, and they maintain it, and that's the home resource of google.com. Also, for the uniform interface, a client has to be able to manipulate those resources if they want. Self-descriptive, the resources have to be self-descriptive, which is MIME, which is the internet media types, because that's a description of the resources. This one, next one is an acronym, and this is a hard one to remember. HAOAS stands for Hypermedia as the Engine of Application State. That's what that means. And this is This is a little bit of a tricky one to follow. And I'll show you an example, so I won't dive into it here, but just remember that one. And the sample I have here, I'll show it. And the next one is ID impotency. That states, ID impotency states in HTTP, you can do a GET request to a resource 5,000 times, and that representation or that resource, it's safe to do that any number of times. And doing a GET request should not change the state of the resource, right? So if I do a GET to a URL, and the second time I do it, that resource comes back differently, that GET has a side effect that it's now modified that resource. That does not follow that principle. GET is guaranteed to be ID impotent. Post is not guaranteed, because when you post, you're creating a resource. When it comes back, it may be different than when you requested it. So that, at a high level, ID impotency talks about the modification of resource and which verbs are ID impotent and which ones are not, but it has to have that built into it. So now at a higher level, why you should care about REST? SOAP, if anybody's heard of SOAP, Simple Object Access Protocol. REST, you can actually implement SOAP in REST. I mean, SOAP is an implementation on top of REST. A lot of people compare SOAP with REST. That's an improper association. SOAP is just another protocol built on top of REST, because SOAP uses post and GET at the simple level, but there's all these things that are overloaded in SOAP. There's an overhead, there's an envelope that gets wrapped in, and there's all this overhead that goes into SOAP. And if you build a REST system, or you build something in HTTP that follows REST constraints, you're bringing in these principles. It's simple because the concerns are separated between client and server at a simple level. It's scalable because you can easily load balance that across multiple web servers, which is how Google and Facebook is able to do what they can do, because of the fact that HTTP is scalable and it's baked into HTTP. So thus REST specified that has to be baked into there. And because of caching, it's more performant, which a lot of the large sites, a lot of people implement caching or use caching to keep the requests down to a minimum on their server. So this is a description between 2006 and 2011, just from a high level. This shows how much more companies and API publishers have gotten away from other things that are more complicated and gone back to simple REST principles and REST guidelines. You can see there's a drastic drop in the usage of SOAP APIs between these years, almost to the sense that REST took over probably more than half of the implementations of SOAP, and other things have declined since then. The only two that have gained or increased are JavaScript APIs and REST APIs. Google uses JavaScript APIs heavily. Other people prefer REST over JavaScript APIs, but that kind of shows that going forward, JavaScript APIs and REST APIs are what everybody is moving towards. It's a simpler way. You can point somebody to the HTTP spec, which is the easiest thing to do. When I say I implement a REST API, I can point you to RFC for the HTTP. As long as I follow those guidelines, both you and I know that if I say I have a REST API, you expect for it to have status codes, resources, media types that are supported, and so on and so forth. All these other things come with it out of the box. So
what was in the other slice that was 3% to 1%? Like what used to make up in 2006?
So as far as APIs for that, so it might have been similar. So you would have had SOAP, you would have had REST. XML RPC is on there. That would probably have been custom APIs or some other implementation that people were using. Trying to think off the top of my head, I couldn't think about it. Yes, Nick?
Do you think that these charts also are an indicator of why JSON is becoming a more expected response, because we're moving towards a more RESTful web?
That's actually a good point, that a lot of these, and I had another slide that I removed, but because it wasn't that relevant, but a lot of these APIs now are removing XML as their preferred response type, and they're going to JSON, which is JavaScript object notation that you can pull in and out of JavaScript. Because a lot of these APIs are working together with REST and JavaScript on the client. So it's easier to serve up JSON representations, and then you can pull that into JavaScript and use that however you want in there. And the sample I have actually does exactly that. So I won't go to this because I think I'm already like kind of behind. It's already after 11. So I'll give you all these slides, and you can look into what makes an API not RESTful, and there's various things. Basically, you start to break those constraints. So now at this point, your head's probably spinning, and this is probably how you feel. So now I got an example that may solidify it a little bit better. So what I have here is this is a web page that's running on a web server I have locally. But at this point, I have this page loaded up, and I tied into the Google Plus API, because they have an unauthenticated API where I can send a request to and get back information about profiles. And I have 2 users here, and this is making a call to the Google Plus API, and it's specifying, and I'll show you the code, it's specifying that I want the data back in JSON, and it's then pulling that into JavaScript and just loading this stuff into the page. So between this page, the only communication is happening between this page and Google server. There's no intermediate server in here. So when I click this button, I can actually pull information from Google Plus, because on their profiles, they accept a JSON accept header. So I can tell when I make that request, I make a request to you, Google, I want this resource back in JSON format. Then I can pull in all those little data points and slice and dice them, and you can see that Kai's profile here looks drastically different than what it does on Google, because I'm able to pull down the different data points and then format it however I want and throw it into my page. The same with Mark Woods here. I can do the same thing. I can pull back a profile picture. You can specify the different sizes you want for the profile picture. The Google APIs are very, very good. They're very well documented. Yes?
Could you pull up the developer tools and actually show the network?
Yes, actually, good point.
By the way, I have an observation. As you see, Mark is more interesting based on his profile. Right? Native Congo line.
So this is a Chrome developer tools, if you've never seen it. When you're in Chrome, you just hit F12, and these developer tools come up, and you have a console, you have a network tab, and now you can see when I click this retrieve Google Plus user, you can actually see that request that was kicked off right there. And I actually made a request to googleapis.com/plus, and if you click on that request, and you can actually see they use a proper status, or a status code 304 not modified. It detected that my client already requested this once, and it says this resource has not been modified, so client, just serve it up from cache, because I don't have anything new for you. If Kai were to log into Google Plus and change something on his profile right now, and I did another request, it will respond with a 200. And then if I did it again, it will respond with a
You could do your own tests and stuff like that to determine which were the best ones.
Absolutely, and that's where the proxies come in, because then you could use a proxy between you and Google Plus that actually implements that as well. So here's a response that came back from that request. And actually, if we look at the headers here real quick, you can see the type that I specified is application JSON. So I told the server, I accept a representation of application JSON. So I want application JSON media type. And then if you look in the body, here is the actual JSON data that came back. And here's all the data points that came back. There's an E tag, that's another header that's used for caching or identifying if a resource has been modified or not on top of caching. But then you can see it has occupation, what Kai's occupation is, what his gender is. Then it has URLs that he has. It's a collection of URLs he has in his profile. And then further down, it has his tagline, his bragging rights, about me. And then it also has an image with a URL. That's the URL. So if I were to copy this right now, just out of here, and I would throw it in another browser window, I can see there's Kai's picture, and there's a parameter on the end here where Google allows you to specify the size of the picture. So if I were to do 300, I would get a much larger picture back. So you can specify, I want a 200 by 200 or a 50 by 50, a little thumbnail. By default, they just serve up a little thumbnail because they don't want to serve up that much data. So in this example here, you can see all the different data points that are actually returned when I tell Google Plus I want a JSON representation of this resource. So now the URL is different, but imagine for a minute that the Google Plus profile I go to with my browser, the browser is going to say text HTML, it serves an HTML. If my client then just uses, in this instance it's not true, but imagine if I use that same URL, but I switch the accept media type to JSON, I get back a programmatic representation of what that resource is. It's the same resource, it's just two different representations, two different media types. So now I have another one, and I'll show you. So all I did was I had other, so you can choose, you get the user string from Google, and then I just have it so you just plug in this user string into here, retrieve Google Plus user, and there's Brad's profile. And you can do this with any Google Plus user, and this is the unauthenticated portion of their API. If you want to get more details, then it actually will ask the user, this person wants it, like when you install an application into Google Plus, for instance, it'll ask the user, do you want to grant this application access to this data? And that's the programmatic API is then going to use that authentication to allow me into his Google Plus profile and get even more information out. This is the unauthenticated API. This is stuff that's publicly available, so that's why there's no authentication here. So at a high level, that's a good client sample. Now what I have here is I can show you real quick how this works on the client. It's all in this index HTML page. And what I have here is the script that's actually rendered. So if anybody's familiar with jQuery, I'm using jQuery here, which is a JavaScript framework for doing things on the DOM, for modifying HTML on the client. And what I do here is I have the buttons hooked up, and then when you click on the button, it calls this retrieve resource. It passes in the Google Plus user ID. It has the full Google Plus URL. And then what it does is it does what's called an AJAX call, which is asynchronous JavaScript and XML. It allows me to make a web request from the web page. So you give an AJAX a URL. By default, if you don't specify, it's going to do JSON, I believe, or that's probably Google Plus has that API wired up, that if you don't specify an accept header, it's just going to serve you up by JSON by default. And then you tell it, when this request comes back, so when the response comes back, I want you to call this function in JavaScript, which is display Google Plus user. So then all I do is I have the data that comes back in that response, which is what you saw on the pane, and then I can go ahead and do data.displayName. I modify the URL to get a bigger URL, image URL. And then I put in places live, data.places live. So because it's served up in JSON, I could immediately use that as an object in JavaScript. I don't have to take in XML and then transform that into something else. JSON is automatically plugged into JavaScript because it's JavaScript object notation. So I can just take that response that comes back from that server and just start plugging it in with jQuery to elements on this page. So this whole example, this whole page was at about 80 lines of code to do all that you saw of getting the resource, plugging into the page, formatting it, and all that stuff. So it's very easy to use these things and to use these APIs that are available. And there's the buttons, and I just have the value of the user ID, and when you click on it, it sends a request. If there was a failure of that request, it would be handled by this failure method where I just show, there was a problem getting users, and you can actually see that here. If I put in a wrong ID or an invalid ID, Google will actually serve up a proper response code for that Google Plus user, and it says this was not found. And they actually return a resource with error information in it. Now, I didn't even use that information. I just looked at the HTTP status code, saw that it was a 404, and then I can do whatever I want. A lot of times what APIs will do is they'll return a 404 with additional information in the response to say, here's additional information that you can wire up, or here's other error codes that point you at a more specific problem. So a lot of times we'll do that. I'll overload the status code. So I'll return a 400 bad request, but then in the body I'll have like a 400.1. And that means that this resource that you requested was not properly formatted. And then we'll put that in the documentation when we have a client integrating with us, and we'll give them that documentation. Say, if you get a 400.1, it means specifically this. If you get a 400.2, you're doing specifically this wrong. Because the status codes are at a higher level, they're more generic. So then that allows our users to drill down to something more specific. Say, oh, it's a 400.2. I didn't specify a name for that resource or something like that, or whatever the case is.
And that's helpful for clients because then on their side, they can actually go to that and then show error codes that are
Yes,
More meaningful and
absolutely. So they can do a better capture of those errors and then either log that or show that to the...
function that into other actions.
Exactly. So that's the first example I had. The second example now is going to be so that's the Chrome Developer Tools, which is pretty handy for debugging things on the page and looking at the requests going out and coming back of in your browser session. So that's very powerful. If you use Chrome, all you gotta do is hit F12 and just start picking through this stuff. There's tons and tons of good stuff in these debugging tools. The next sample I have, this is a Google Chrome app called Postman. And you can just go to the Google App Store and you can install it. This is extremely useful. I use this all the time. I know Nick uses this all the time. I think you've been using this, or we also use another one called Firefox REST client, which is a plugin for Firefox. This is basically a REST client that I can just load up with Google Chrome and I can make requests. Like for instance, here's one, and in this you can specify, I'll hide this, you can specify the URL, you can specify what verb to use, you can specify any headers. If you want additional headers or you want to add additional headers, you can put them in there. And then you can go ahead and send that request. So right here, I'm not specifying an accept parameter. So all I'm going to do is I'm going to send this request to Reddit. And you can see now that the representation I got back is an HTML representation. And you can look at the headers, the response headers, and you can see some information here. It's saying the content type of the response is text/HTML, because you didn't specify, so that's what it serves up by default. It has the content length. Here's the length of the content. Connection keep alive. Connection keep alive means that this connection will not be closed right away, but it'll be held open and that connection will be reused on multiple requests. Almost all web servers use keep alive connections now. And various other information here. The ones that start with X are kind of custom headers. So if you have a custom header that you have in your documentation or you have in your API, you should prefix those with an X dash. That's, again, specified in the 1.1 specification. If you have a custom header, and you can have any number of headers, it's a custom one that's not publicly known, you should prefix it with an X and a dash. And that tells everybody that this is a custom header that's not in the specification. So you can see here, and I also got cookies that came back off of that, which are tracking cookies. So even though I asked for the page, you can see here that they're using cookies to track what I'm doing on their site, which almost all sites do that now if you do requests like this. So that's an example of just a raw HTML. I didn't have any custom headers or anything. Now I have that same request, and what Reddit does here, and some sites will do this, you don't specify an accept header in their API. You just suffix the URL with .json or .xml, and they will give you back a different representation. Now, according to REST constraints, that's wrong. You're not supposed to do that. But a lot of places do it, and it's easy enough for them to communicate because a lot of people don't understand the accept header, so they just say in their API docs, hey, just append .xml or .json. If you do funny .html, you get back HTML. I'm not sure if that's accepted or considered okay in the HTTP 1.1 spec, but I'm assuming since they do it, there's something in that it speaks to there. So now I don't have an accept header. I'm doing the same GET request. So all I did was append on .json. I'm going to hit send, and you can see now I get back a JSON representation of that same resource. Now this looks drastically different, but according to Reddit, this is that same resource I asked for before. It's just a different representation because I wanted a different format. And in here you can see all the same. You'll have children, you'll have whatever their model is around this, and you can go to the Reddit site and they'll have documentation on what all these things mean. So another couple of samples I have here. So that's Reddit. I can then go down, let's say I have a comments. So Reddit, if you've gone to Reddit, there's a post and then you have comments under that post. I can do the same thing with a comment thread. So I can send a request to a comment thread, and I will get those comments back as a JSON representation off of whatever that post to Reddit was. So you can do this .json thing with any portion of Reddit, and you can read their API. I know, Nick, you've done quite a few things with Reddit of reading data out of their API and running analytics on it and stuff. So this is, if you want to play with stuff, this is a cool way to play with it. I mean, you can start pulling data from these APIs and throw it into a database or whatever you want and start to build visualizations on it. There's a Reddit subreddit called Data is Beautiful, and it's just people that use APIs like this to build visualizations and graphs of different data sets that they pull in. So,
And did you say that Firefox had a...
Yes, Firefox is called REST client, and Chrome, in the Chrome store has Postman.
These could be used for like troubleshooting
Absolutely.
an app or rolling out even.
Absolutely. So at work, a lot of the REST APIs we have internally, we have many bunches of collections of REST requests to different environments. They have this environment thing. So if you have different environments like a dev environment, a test environment, a production environment, you can have the same request, but you can put different parameters in if you're going to a different environment. So it's got a lot of functionality in here that's pretty nifty and pretty easy to use. So the sample I have here real quick is so now on the server side here, I have a web API project, which is an MVC project, and I have a people controller. This people controller, so I'll do a couple requests. Let's first do get people. So for get people, I have localhost /API/people. So this is, I expect to get back a representation of people from hitting this one URL. I'm doing a get and I have one header. And this API actually uses the accept header. I'm saying, I accept application JSON. I'll send this request. And you can see here, I get back a collection of people. Now, the hate OAS that I had before, hypermedia as the engine of application state, that states, you see now how there's links built into these resources? That concept says that any resources that are returned should have links embedded in them, that then the client can simply pull in that link and go to a transition to another resource that is linked to this resource. When you visit a website, you're already doing that. When I click on this link right here, it's doing the same thing. That's hypermedia as the engine of application state. I'm clicking on that link, which transfers me to a different resource. Same thing. So you can see here, that's a collection of people, and I'll try to hurry up here so we can get time for questions. That's a collection of people. Then if I want to get a specific person, you can see I just appended on the user ID. Now when I go a level deeper in the URL and I do get API people 7, I get back that single person. It's returned in the collection of people, but now I'm zoning in on one resource. Here's that single person that you're getting back. Now let's say I want to create a person. So I have a new user named Sean Chambers, his date of birth, and I'm going to do a post now because I'm creating a resource. There's headers here that state, on the response, I accept application JSON, and a post that the content type that I'm posting to you is also application JSON. That allows the server to know if it's going to accept that media type or not. So I'll go ahead and hit send here to send this request. And you can see here in the response, I now get back my original resource. So post dictates that it should return the original resource that you posted with any additional information that has now been added to it. So you can see here the server has given it now an ID to identify that resource. It has put in 2 new links to other resources that can be transferred to. It has added a hobby, which it's added consuming REST APIs to the hobbies. And it has calculated an age given my date of birth that I set up. So the server enriched that resource with additional information and then returned it back to me. And you can see actually the status code here was 201 created, which means that resource has been created on the server. Here you go. So now at this point, now I can actually I can get a person. Oh, I already did that one. Now if I update a person, so let's say I want to update that person. Here's the first example I have. So let's say first I update, I forget what ID, I hard-coded it. Was it 7? So let's say I do, I just had it hard-coded on the server. So I do a put on this and I update it with those hobbies. It'll now return with the rest of the information that I had on the resource, but it set the hobbies to only those 2 hobbies because I updated the resource to only those 2 hobbies. But it also returned all the additional information. Puts are not required, you're not specifically required to include everything. And it also depends on the API. Some APIs, if I only include those things, it may wipe out the rest of the data on that resource. It depends on the API to say, you don't have to pass all the information. You can only update these things, or if whatever you pass, I'm going to flash that resource on the server, and that's exactly what you're going to get on the response.
That's why documentation is important.
Absolutely, because that will show that if there's any side effects or what the outcomes of that situation is. If I do get people 7 or 0, this actually returns a 400 bad request to say, you client, you did something wrong, and you can see here invalid person ID. So that's like if you couldn't look it up in the database, you would return well actually in this case, I should have returned a 404 not found because that resource was not found. But a 0, maybe a 0 is completely invalid for IDs. So in this example, let's say I put in a person ID that's something along these lines. Now I get a 404 not found. That resource has not been found. So maybe in my API, a 0 is an unacceptable ID to pass to the server. So quickly through the samples up to that point, that kind of shows, and then you can send, this one just sends a delete, which will respond with 200 OK. That resource has been deleted from the server. Now, if I were to do a delete again, now, delete verb is guaranteed to be ID important, so you should be able to hit delete multiple times, even though what some people will do is the first time you delete it, if you try to delete that resource again, they'll return a 404. That resource has been deleted from the server. But that's one part of the spec that I I don't understand that part, that you can do a delete multiple times. Apparently in the spec, they state that you can keep doing the delete and the server's just gonna respond with 200 OK. But if you would do a get on a resource that doesn't exist, it should return a 404. So, and I think that was pretty much all the samples I had here. And then the only other thing I had, we can do questions really quick, is, as I say before, the Google Plus API and the Google, they call it the Google Data Protocol. This is an example of good documentation of a resource. They have people, and then they have resource representations, so they have the representations of that resource, and they dig into all the data points that you would get back and what they mean. And then if you go down, they describe these data points to say, here's what all these mean, here's acceptable, not acceptable, here's their value, is it a string, is it an object? They may specify it's an integer. I don't know if there's a list. URLs will be a list. And then you can see it, they dig into the URLs. They say within one URL, you'll have a label, a value, a type. So this is an example of good documentation in my mind. It documents the media type. It tells me what I'm going to get back. And then they go in to show what methods are supported on this resource. Now, Google kind of overloads because they're trying to coin it kind of makes sense with all their other APIs. List by activity, which I'm assuming that makes sense for Google Plus, that's something they use commonly, is list by activity. But you can see here you can get a person's profile. So that's the endpoint I used when I was loading your guys' profiles. I was doing a get on a person, which is exactly the URL I had in my client there. So I just copied and pasted this. I specified a get. I had the user ID, which is required. And then here's an example of what I got back. And Google also has these cool things. You can use this API right from their page. So if I put a user ID in there, I can, and it's basically doing the same thing as my site did. They just do it right in the page. So
Yours was just better.
So that's a good example of, if you want to look at good API examples, there's plenty of them out there, but Google seems to be a pretty decent one. Originally, we were talking about Twitter. Twitter is actually a bad example of a REST API. They have good documentation, but they have URLs that say destroy, but you do a post to that endpoint. So you're using the verb for create, but it's actually deleting a resource on the server. So they're diverging, and again, they're diverging. It's not to say that you have to follow all those constraints. It's just then they consider that your API is not RESTful, or at least in Roy Fielding's eyes. So I really ran short on the time. I didn't think it would take that long, but I'll pass around these slides. These are further reading. There's a good book on O'Reilly's called RESTful Web Services. That is a really good book that has a lot of good examples, and then the last part was questions and such. So, any questions? If one other tool that I had running the whole time here is called Fiddler. If you've never used Fiddler, this will, if you just have it running, all your traffic will go through this proxy. And now with Fiddler, I can see all the URLs I went to. And where's the one that I started loading from? Let's see, Google APIs. I don't know where it is here, but you can actually click on a request, and Fiddler gives you a lot of information. So for instance, for this one, when I went to Reddit, and I can see, where can I see the response? So there you go. There's the request headers that were made to the server, along with all the headers. And then here's the response, and you can look at raw. Here's all the response that came back from the server. It was probably SSL. So that's why it looks all weird like that. Yes, SSL, you can also have Fiddler decode SSL traffic because that's encrypted. But Fiddler's also a really good tool for debugging problems with web APIs and stuff like that. Yes, Nick?
Do you have any recommendations for packages or libraries inside of Visual Studio that can help someone get started?
Oh, for like C#. So that's a good question. Microsoft has ASP.NET Web API. Web API it supports RESTful API. So you'll have a controller like this, a people controller, and you can see my methods are called get by ID, post. So basically what you do is you just set up the verbs on your controller, and the Web API will see that you made that verb request, and it will automatically route those into that method, and then you can do whatever you need to do. If you need to make a call from a REST API to a REST API from C# code, a common one that we use is called REST Sharp, which is a C# implementation of a REST client. You can roll your own. There's you can use REST Sharp, or there's a whole bunch of web. It's called web client or HTTP client in .NET itself that you can use to make web requests. But REST Sharp, I would probably recommend if you're using C#. That's a really good one. That's really well supported, and that allows you to make calls to other APIs from your C# code.
Do you prefer to use the built-in JavaScript serializer, or do you use something like Newtonsoft?
That's another good point, is if you're using C#, a serializer for serializing to and from JSON. They have one built into .NET, but another good one that is written in .NET is called Newtonsoft JSON. And that guy, the one he built, adheres to something that's more widely accepted. There's certain pitfalls in JSON, like with dates and stuff, that this language will return a date in this format, but Newtonsoft JSON, that framework, does a very good job of serving all those scenarios. Under here we have the IIS server, which is where the site is hosted. So if you're using Microsoft and you're hosting the site with IIS, either on a web server or on a local machine, under this site, which is just a default website, you'll actually see here it's going to be handler mappings. Yes. Oh, it's actually MIME types, I'm sorry. Handler mappings are for something different, but these are actually all the internet media types, but IIS still calls them MIME types. These are all the MIME types that are supported by IIS out of the box. So you can see if we find text HTML, should be down here. There's text HTML, and it's got .htm, .html. The MIME type handlers map up an extension, so like .htm to, and it'll route that into that specific MIME type before the request actually gets to your page. So this is all handled by IIS, and in there we should also have application JSON. Actually, they don't have that by.
No, Sean is a great man to work for, and he's also an innovator at ACI, so
It's
it's a
great.
pleasure to work with someone who's so knowledgeable in his field.
So great. Great to hear. Nice thing to say. I think, Terry, you're going to have to do it, man. You're going to have to.
That's so unique that you would say about your boss in his presence, you know?
Somebody step out the front door for a minute.
You'll hear the even better things I say once he's gone.
There's a lot of very valuable information. The application of this platform is something that's really going to be important going forward in development of internet applications.
Just in a word or a couple words, what was the biggest takeaway for you?
You know, I think a lot of people got different things. We all use different assets in developing software and stuff like that, processes. And some of the things I got out of the how to troubleshoot your app, how to reach down into the actual data transfer and stuff like that, and see what's going on. That's more what I got out of it. We all use many different platforms, and there's so many that we really don't even understand. But when we're getting back from it, what we're looking for, then everything's fine. But when it's not fine, is when we go to digging.
Right, right.
And that, I think that's what I got out of here today.
Nice, nice. Thanks for coming.
I enjoyed it.
What was the big takeaway for you today?
Well, one of the biggest takeaways for me, being in the line of work that I'm in, is actually understanding the terminology behind a lot of what goes on with REST API systems, but also a better understanding of how it actually works, like the intricacies of how it talks to the other systems and servers and pulls, and the whole way that it works with different servers and such. Really helped out with our line of work because we do a lot of API integrations and stuff like that. So the terminology.
And your line of work is largely Salesforce?
Salesforce integrations, CRM systems in general, but mainly Salesforce type work.
I like that too. I liked how Sean also kind of gave before and after examples and just took the time to set up so we could literally see the live communication. I thought that was really good.
Yeah, that was really nice being able to see that. Now I'm actually going to utilize a lot of those tools now when I'm debugging and troubleshooting some of the API issues we run into.
Yeah, I think we all will. That was good
That
stuff.
was really good.
Well, thanks for coming.
Yeah, thank you.
All right, so finished the web standards class with Sean Chambers at CoWork. Tell me, just a takeaway, something that you learned that maybe you didn't know before, or something that you're thinking about.
Well, it was just interesting to see the REST API explained.
Yes.
I'd seen it before when I was working with the PayPal APIs, and it kind of gave me an idea of how just everything was based on what everything was based on, because every part of the web needs something to stand on, and HTTP was kind of that base, and then kind of the idea of REST was like the next step, and then everything kind of branches off of that. So just to get an idea of the basics was really helpful in understanding everything that's at a higher level.
Great. Terrific. Thanks for coming.
No, thank you.
Cool.